Our next talk is Microservices in Python by Rory Hart. Rory is employed by Biarri, where he helps deliver mathematical optimization tools over the web to businesses in a wide range of industries. His focus is on ensuring he and his colleagues use the best engineering and technology to deliver tools clients need. Ladies and gentlemen, Rory Hart.
Hi, I'm Rory, as mentioned, and I'm a software engineer. So I work for Biarri Optimization. I'm here to talk about microservices in Python and microservice architecture. I'm not going to go too deep into the ins and outs of microservice architecture. There's a lot of people, a lot of talks out there already talking about microservice architecture and why it's good and what the drawbacks are. But I want to talk about why we chose microservice architecture as a smallish Python shop and what Python tools we've chosen to use to do this. So I thought I'd better lead with some definition. Show of hands, who has heard of microservice architecture before? Oh dear, I'm going home now. Who's actually using them? Oh, there's a few. Cool. So I like to think of microservices as single-purpose services, oriented around a domain concept rather than a technological concept. So what I mean by a domain concept is a user is a domain concept, a message is a domain concept. And at Biarri, we deal with a lot of trains. So for us, trains are often a domain context. And microservices are used by some quite large organizations, such as Netflix and realestate.com.au here locally. And that was really interesting, and they've been talking about them a fair bit, but all the examples are really big, and so I thought I'd give a talk about why a small shop is using them. Now this is a definition from someone else, just in case you don't believe me. This is Martin Fowler and James Lewis from their fairly seminal article on microservices. So I thought I'd highlight the end of that, the lightweight mechanisms, because we're using REST, and it's nice and small and lightweight, and often that's kind of lost in the crush of the how big or how small. Anyway, moving on. So at Biarri, we build software as a service tools. They're deployed on the web, and they all mostly have maths at the core of them. So we solve supply chain, logistics, crewing, and scheduling problems. For example, we help Schweppes plan all of their daily truck deliveries to all of the stores and milk bars throughout all of the major metropolitan areas. And we deploy all these applications through a single web portal. Clients really like this. They have a single login to all of their tools, and it's really easy for the sales guys to kind of convey how it's going to look and feel before the client even signs up. But we had a problem. We started with a single code base, and I think this is true of most companies. It's a natural pattern to follow. And you initially get a lot of velocity out of that, and you're a small team, you're working together, and you collaborate really well. Everyone knows what everyone else is doing. But 5 years later, and we've got a monolith. It's a big blob of code. It's grown with us over time, and it's still growing, and we're growing. And some of the assumptions that were made in this monolith of code are no longer true. Some of the mistakes that we made in the beginning are still haunting us. And it's really difficult to change this monolith of code while still making a profit, still going out, satisfying customers' needs, and doing what we want to do. And it's really hard to adopt new technology. We want to try this new cool thing, or we've got this really great idea, but this monolith sits there going, well, you have to make sure you interface with me properly. And our deployments are taking more time, and frustration's generally growing within the company. Not just us software engineers, but the business guys as well. So this is something of what it looked like. This was a diagram, and all the diagrams I drew were to kind of communicate the microservices idea internally when we first started toying with it. The big box is the monolith. That little box off to the side there was an experiment in running something slightly separately. And then the big blob down the bottom is the database, and all the rest is the web. So we've been discussing solutions for as long as I've been at the company. This has always been a kind of a frustration and a desire to fix. And the first and most obvious answer was do nothing. Like, you build monoliths, right? We're still delivering projects to clients. We're still making a profit. And we could go refactor this monolith and automate it more. And one or two big bang projects, and we would, make it better, and everybody would be happy. But those projects, those refactors, would be quite disruptive, and we'd find that we'd put at risk our client projects that bring the money in the door. And we really felt like it was only going to stave off the inevitable. We're hoping we'll continue growing at the pace that we have been growing. And at some point, this monolith is just going to ground to a halt again, and we'll have to deal with it again. So we looked further afield than just kind of refactoring. Second option, and that was that kind of little guy sitting off the side in the first diagram, was integrating on the database. What we'd do is we'd deploy each tool separately, pull some common library code into each one of them, and then deploy them. And then they'd all look at the same database and share the data that way. We could do this incrementally. We did it once. We pulled it out and ran it separately. And it's marginally better. But as soon as we want to change library code or change the database, all of those tools, we need to go through them all and go, okay, how are we going to break it? How are we going to fix it? How are we going to deploy all those things at once? So not much more flexible. And on the technology side of things, we're still left in a position where we really can't experiment too much with technology. Like, can't go and rewrite all our libraries in another language and then deploy that tool just for one project. Now, when you talk about microservices, the elephant in the room is often service-oriented architecture. It's often one of the first things that comes up. And service-oriented architecture, for those that aren't familiar with it, and please excuse my definition because I struggled with my understanding of it for quite some time, was you divide up your code base somehow, and you run some services of some description. And this is what I struggled with, is where do you divide it up? Where do you delimitate your code? Where do you decide, okay, this is a service here, and this is a library here, and this is, So it wasn't clear, and the standard documents, and there are standard documents, are really scary and big and enterprisey, and for a small Python shop, it didn't seem like a good fit. And it seemed like it'd still be a really big project, like it would be a big bang kind of, okay, we rip this all out and we put it here, and then bang, we're a service-oriented architecture. And service-oriented architecture is really not cool, like, IBM sells it. And then, of course, there's microservices, and this is why I'm here. They're quite well defined in their own little way. There's lots of articles talking about, especially breaking up a monolith and kind of the standards to adopt and how to approach the problem. And those articles really fit well with what we were looking at with this monolith and these kind of these lots of decentralized projects, but they're kind of all having to be governed by this central monolith of thing. So what monoliths offered to us was we're able to go, okay, you're a project, you're delivering to your clients. You can go and make the best decisions that you want for your client, and that might be, using a completely different language to what we've done before, or using a completely different set of libraries or a different web framework or whatever. But it also says that you standardize on the edges, that where you talk to someone else, where you integrate with somebody else. You make an agreement. I will always talk to you this way, and you will always talk to me that way. And in theory, it all works out really nicely. And we've got a few deployed now. So this is the second of the internal diagrams, so I apologize. So we've still got the monolith, that still exists, and we've still got that big block of database there. But we now have some microservices and some tools deployed using those microservices. So we've got the tools up the top there, and they've got their own little databases, and they're doing their own thing, and they're even using some new technologies that we've wanted to use for a while, but haven't been able to. And then we've got our microservices running down there, but they're integrated with the existing Monolith database. And then we've got some math solvers and engines that do big, crazy calculations that I don't understand, and we employ some very smart people to build over there. So this is what it looks like now. And we're already better off. Like those tools up the top there, those two tools that we've got, they now use a very forward-looking API. We don't anticipate having to change those in the near future. And they use the things that are best suited for them. And this is where we anticipate being next month. So now the difference is the microservices own their own data, and the monolith now talks to the microservices to perform those tasks. And we're able to refactor that monolith because there's no large amounts of active development trying to get work out to clients going on in that monolith anymore. That if we go and change an API, we know that we're not trying to, we don't have a project that's trying to hit a moving target. They're not coming over to our desk going, I want to use this thing, but I know you're going to change it at some point. When's that going to be ready? And that kind of back and forth that really makes it really difficult for us to go and change things is minimized. And this is where we hope to be in 6 months. There's no more monolith, it's gone. We've refactored it away by breaking it up and turning its code into libraries or just completely deleted it and turn them into microservices. So we've got a few microservices. We've got our users and our authorization system and our little workflow stuff, which is a domain concept that's generally valid within most of our tools. And we anticipate there'll be other microservices. Someone's already come up and said, hey, I need emailing. How should we do this? And I've said, go and write a microservice. So we have a path forward now, and it's a path we're really comfortable with. And I anticipate being able to wax more lyrical about where we've gotten to next PyCon. But I thought I'd share with you some of the Python tools and libraries that we're using, because we found that Python, because of some of the technical decisions that microservices espouse, is really well suited to the microservice architecture. So I mentioned all of our microservices talk REST and web stuff. So the first one that was obvious to us was lightweight web frameworks. Something like Flask or Bottle, Wurtzhog or Cherry Pie, we're using Pyramid. And they're really easy to just build a single file application. There's very, very minimal bootstrapping and startup involved. And they're very simple little beasts, these microservices. I think the biggest one is about 350 lines of code. So you don't want much overhead in it. They don't really need much. So something like Django or, it didn't seem like a good fit to us because of the large overhead and assumptions that Django makes. So to talk to these APIs, we chose requests. It's got a fantastic API. It talks REST really well. And it has some really nice advanced features. it has some sessions where it can keep hold of things like your headers and your authentication throughout many requests. And it also will do things like connection pooling. So if you've already got a connection to a HTTP server open and that's available, it'll just go and reuse that, which reduces your connection speed, your connection time to a microservice. So this is what a Eurolib2 RESTful request to GitHub looks like. It's not very nice and pretty verbose. And this is what it looks like with requests. The difference is astounding, I think. So it's when you're going to go and set up these microservices and talk to them, you don't want this big overhead of going and setting it up. You just want to go, I just need this thing. It's done. You don't want that kind of big barrier. And then the extra advanced features are just as nice looking. They're, bam, you've got some auth stored there, and you can just keep reusing those connections, and has some more advanced features beyond that you can tailor around with, but it's basically all it is. So with microservices, there are drawbacks, obviously. And one of them is you're going to have a lot of things going on throughout your operations. A request at the front end from a user in a monolith, it all happens in the monolith and you're done. Whereas coming in on a microservice architecture, it'll hit one of your front ends and then fire off 10 requests into your microservices, and that'll generate a whole cascade of behavior. And being able to debug that and follow that is really important, because when it breaks, you want to be able to follow what's going on. So I wanted to highlight the Python logging package because it's really fantastic. All of the libraries that we use it already. So all we need to do is go and turn it on and point it at a file and set up our formatting so that it obeys the kind of things that we expect in our logs, and then we can write logging in our applications and pull it all together, aggregate it together, and keep track of what's going on. Be able to go back and perform some forensic analysis and see what happened if something's going wrong. We're using Tox for minimizing our continuous integration build configuration. It's a build and test tool. It sits kind of on a layer above your testing tool, Nose or PyTest, for example. And it'll run all your tests for you, and it'll manage your installability of your packages so that you know what's going on. You know that it will install. As I said, it minimizes the amount of boilerplate that you're doing to set up your CI. Which is fantastic because we've got lots and lots of these projects now. Every single microservice has its own build, and multiple builds, in fact. Now we're doing lots of installing of things, and we're building lots of packages. So Devpi provides us with a Python packaging index proxy and a repository. So you can run that locally, or you can run that on your server, or you can run that both locally and on a server. You can ship your own packages to it. And you can also ship compiled wheels. So if you've got a C++ or a C package that you're using and you have to sit there, we use NumPy, for example, and that sits there doing a long build. And every time you set up your virtual environments, you have to go and build this thing. It's really frustrating. And Richard Jones is doing a talk all about Devpi later. And it's funny because I actually found it through a deprecated project of his that kind of tried to do the same thing, and then he just put a banner across the top saying, "Don't use this anymore." So I think we've all heard of Virtualenv, I hope. You can install packages into a walled garden, Python packages. But PyEnv is a little bit newer. I think it was stolen from the Ruby guys originally. We won't mention that. And what it does is it allows you to control the version of Python that you're using in your project. And with microservices, we suddenly now have a very clear path on how we're going to move to Python 3. We can just start a project using Python 3, and it just uses Python 3. So to manage switching between all of those projects, because we're going to end up with some legacy stuff that uses Python 2.7, Pyenv will be a great help. I say will because we haven't actually started using that fully yet, though one of those tools is about to start using PyPy, so it'll handle your PyPy or your IronPython or your, what's the Java one again? Jython, yes. So yeah, if God forbid you're using Jython. Another disadvantage of microservices is you've got a lot going on in your operations. There's a lot of things to configure, a lot of things to play around with, a lot of changes to make. So SaltStack is a configuration management tool similar to Chef and Puppet. One of the reasons that we chose it was because it speaks Python and YAML. And we couldn't do microservices without a tool like SaltStack. It's just beyond comprehension. There's too much twiddling and fiddling, and we couldn't reliably be able to deploy and maintain what we've got without a configuration management tool. And this is an aspirational slide. There's a library that realestate.com.au have written called Pact. And what Pact provides is a mock server that your consumer of a microservice talks to in its tests. And what this service does, this mock server does, is instead of proxying or passing it on to the real service, what it does is it remembers what's been asked of it. So the consumer says, I'm going to request this and you should give me this back. And it goes and does all of its tests and make sure that its code passes in the manner that its writer expects. But the mock server remembers all of these expected responses and expected requests, and it'll turn around and it'll talk to the service and say, hey, I have this request for you. And it'll get a response back. And if the response doesn't match, waves a red flag, breaks the build, those two guys have to get together and have a chat and say, look, you've broken my build, or I've broken your build, and we need to fix this. So this package, unfortunately, was written in Ruby, not in Python. So we're writing our own version in Python, and we're hoping to release it in the next few months. So as a small Python shop, we've chosen a pretty radical architecture, I think. But while the architecture is quite radical, the HTTP and the REST and the general web tech that we've chosen to implement this isn't. We know how to build web servers and web applications. So because of this technological choice, the Python ecosystem has supported this decision really well. It has all of these libraries, it has all of these services, tools, that we can leverage. So we're really happy with our decision so far. It's been very straightforward. And when I first proposed this talk, I was expecting to get into some more technical nitty-gritty for you. But over the period of time that we've been building them, it's turned out that really that's not been the problem. That's not been the issue that we've had. Rather, it's been the communication and the understanding of the situation that we needed to develop over time. So I'd like to leave you with some suggested reading if I've left you wanting more. So the first one is the article that I quoted earlier by Martin Fowler and James Lewis. And it's a pretty long piece of writing. It's more than a blog post. It's quite number of essays, and it really covers everything that you really need to know to first kind of understand what's going on with microservices and what the disadvantages are and what the advantages are. The second one, Microservices is not a free lunch, really talks about the disadvantages of microservices. They're quite bullish about microservices, but talking about the trade-offs that they're made and how to minimize the problems that will create. So it's quite ops-centric and quite interesting. And the last one, if you're interested in a bit more about Pact and this contract testing idea, the guys at DS wrote quite a good article on Pacts, and I suggest that would be a good place to start. All right, I'll take some questions and hopefully I'll be able to answer them for you.
Hi, good speech, thanks. Can you maybe talk about any scaling or scalability issues that you might have faced? Because you're talking about you have a very light front end, but I can assume if something gets really busy or computing resources are required, do you then start, proxying, or how do you scale this thing and still keep it micro, not macro?
So I can't speak directly to that because one of the problems I always jokingly say is we don't have load. We don't have user load. We generally have tools that have a very small number of users, but on the back end, it'll do a big maths job with 10 gig of memory and CPU for a couple of hours. And so we have that sort of load, whereas we don't have a web load where we're having to worry about that. More generally, some of my friends who are doing microservices, they just say, well, it's a web server. You just do what you would normally do for a web server. You replicate, you load balance, but you do it on your internal systems rather than your public-facing systems.
Hi, if you go back to your diagram, you can see that you have quite a complicated dependency graph of like
this
things.
one?
Yeah, things like T goes to P, which goes to U, which goes to U.
Shall we go for that one because it's a little less all over the place?
How do you deal with dependency management? Like if you need to deploy a new version of something that depends on a new version of something else, and that type of thing.
Well, there's two sides to the answer. One is it's very important for microservices not to hang around in development for too long. If you end up in a situation where you've got a microservice that's sitting there and it hasn't been updated, it hasn't been pushed to the server, and then someone's trying to build against that, what are they building against? Are they building against the development one, or are they building against the new one? Another side to that is, what was the other side to it? Oh yes, so the other side is because it's a microservice, because it's not, because it's a RESTful service or a web service or a networked service, because you're not linked together in a common process, in a common set of code, you're less likely to end up in a situation where someone's going and using undocumented behavior. They're going into that library and saying, oh, I'm going to just go and grab that thing that you haven't given me but I need. You've got that strong delineation between services. And so if you want to go and change something, say, for example, and this is the example I always use, you've got 3 sets of bits of data for your user table. You've got your username, your email, and your password. You decide, okay, this whole username thing, it's useless. It doesn't work for us. We don't need it anymore. What do? Well, with a microservice, you can just go, okay, well, we'll get rid of that username column, just keep the email column. And then those things that rely on that username column to exist, we'll just copy the email into a fake user column, provide that version 1 of that API, and then move to a version 2 of the API, and then run both of them side by side. They both use the same backend, and they make the same tricks. And the other thing you're talking about, dependency graph, and this is one of the problems that Pact tries to address, is this: who is using my API? In your continuous integration builds for your service, you have this big long list of contracts with all of your consumers. And when you want to go and change something, you know, oh, these people are using this. And if I want to make a breaking change, something that I know I need and we need to push through, I know that all of these things are going to break, so I need to go and talk to those people and we need to work it out. Or I need to continue supporting that API for the next 10 years because we really just can't touch that thing. No one wants to see it.
I think we're in a similar situation to maybe where you were a few months ago. We've got probably half a dozen different sort of microservices that we're using. We're using some of the components where you're using Virtualenv and like Devpi and that kind of stuff. We haven't really found a good solution that's better than just building on the same architecture, packaging it all into a deb and just deploying that in the servers. So I wonder if you could talk a bit more about your deployment, how you manage that, because we're sort of finding it's a bit piecemeal using sort of Puppet to manage environments and that sort of stuff. Yeah.
So unfortunately, I don't have a very good answer for you yet. We're not happy with how we're doing it at the moment. We're packaging it up and pushing it to the server in a similar manner that we're using Python rather than debs. What we hope to do is one of a number of things. One is a very grey kind of fluffy answer, and that's Docker, but we don't know. We don't know what yet. I see one of the Docker guys in the audience, and I'm meaning to grab them at some point. But yeah, so there's definitely some strong need there, and we've identified that, and we've actually the next major project after this push of microservices work is actually to come along and go, okay, well, we've created this problem, now how do we get it to the point where we're really happy with it and it's nice and smooth? So I don't really have the best answer. I know that other people have some very big, strongly architected continuous integration builds that continually deploy to their stack via various things, but us not yet.
Hi, thanks for the talk. Do you have any advice for people that have quite a coupled project that are trying to start splitting things out?
Yeah, definitely. So we chose some obvious common patterns between most of our tools and said, okay, well, the users was an obvious one, and auth was an obvious one where it's all the tools use it, and we know that we're going to need to address this. So we grabbed that and chunked it off. We did it in quite almost a less microservice way. Some of the microservices, for example, a workflow one, which is basically a wizard tool that remembers steps, and it's a very common pattern throughout of our tools. It has quite a lot going on in it, and we could split that up more. But we made a definite decision to kind of go, okay, we'll make it a bit larger at the moment because we don't have necessarily the best deployment systems and the best way of managing this, and we're dipping our toe into the water and seeing how it feels. So we kind of chunked it a bit larger than we thought was necessary, but to begin with makes a lot of sense because you're a bit less risky.
All right, a big thank you to Rory Hart.